Observe how this robot moves its hands. The action seems almost strange because it is so natural. Even though your mind is telling you that this video can't be genuine, it is. Not only are you viewing Tesla's most recent creation, but Optimus, their newest employee, is also in front of you. And very soon, a factory near you will be home to a lot more of these robots. This is no longer about the future. The manufacturing sector is undergoing rapid change right now, and 2024 will go down as the year of the Tesla bot. While Tesla still hasn't brought C-3PO from Star Wars to life, the most recent demo video we saw in December 2023 was very exciting. Debuting the Optimus Gen 2, the video shows the bot walking much smoother and 30% faster than before. It even got articulated toe sections, making the walking action itself feel far more human. The bot itself is 10 kilograms lighter and gets a neck that can move on 2 axes of rotation. The brand new arms now feature 11 joints and can move faster thanks to improved Tesla-designed actuators. But the most impressive update was the addition of precise tactile sensing on all fingers, allowing for some very fine and delicate hand control. It demonstrated this by picking up an egg and placing it precisely in an egg holder, an action that Moravec's Paradox says should be very hard. But more on that later. All of this is now wrapped in a sleek new Gen 2 body that Tesla says is far better balanced with much improved full body control. It can now perform a squat with ease, reminding us all not to skip leg day at the gym. Tesla has made a big deal this year about moving the manufacturing of their actuators in-house. In fact, back in March, they said that the reason Optimus Gen 1 was operating so well compared to the 2020 debut model Bumblebee was because the team had decided to produce these delicate parts themselves, rather than using off-the-shelf components. Actuators are the bits that convert input signals into the actual force required to move anything from the Tesla bot's legs to the fine motion of its fingers. And this is where Tesla gets to show off. In the brief moments when we see the robot's neck and fingers move for the first time, the subtitles tell us that the neck now has a 2 DOF actuated joint, and the fingers have a whopping 11 DOF. DOF here refers to degrees of freedom, which in mechanics is referring to an axis on which an object can move. In the case of the new neck joint, this means that the neck can now rotate left and right, as well as pitching forwards and backwards, which means that those fingers are very articulated. In fact, the motion of those fingers are now so smooth that Optimus developers felt they had to jump into the replies and confirm that this video wasn't CGI and hadn't been sped up. The really mind-blowing tech is not even the actuators though, it's whatever Tesla is now using to give their robot some tactile sense in its fingers. During the last few seconds of the video, we are shown Optimus handling some eggs, with a visualization of the sensors in its fingers. Now robots handle eggs all the time, but they usually do so with little tricks. They're either programmed with the precise amount of force needed to pick up the egg without cracking it, or they are designed to use some soft rippers that use suction to hold the delicate object. But Tesla went the more human way, and seems to have developed some sort of pressure sensor that allows Optimus to feel whatever it's holding and gauge the correct amount of force to use within those delicate new actuators. This is way closer to how humans actually interact with objects, with the nerves in our fingers telling us things like the shape, texture, and give of a surface, and then sending that information to our brains to process and make the decision of how much force to use when manipulating it. And this is exactly how we've been told Optimus works. Back in March when the Gen 1 was showcased, Tesla presenters made a big deal about their robots learning algorithms. That video of Optimus sorting blocks from a little later on, in September, was another example of it learning by doing, having only received orders to sort the blocks by color, but not how. We don't know any details on this tactile sensing technology quite yet, if we ever will. It could very well be proprietary, but it could very well be used in the robot's feet, as well to help it gauge the surfaces it's walking on, just like we do. When Elon first announced the Tesla bot at the Artificial Intelligence Day in August 2021, the goal was to create a general-purpose, bipedal, autonomous humanoid robot capable of performing unsafe, repetitive, or boring tasks. So a bot that doesn't take away the fun things but can run into a burning building to save someone. A bot that can work at dangerous deep-sea mines, or simpler, more boring tasks like sorting out eggs at the factory. In his vision of the future, Elon sees us only working when we want to, because the labor will be unlimited thanks to these bots. He also said that we will certainly need a universal basic income at that point, but that's a discussion for an economist, which I certainly am not. Anyway, the Bumblebee prototype we did see a year later in 2022 was clunky and slow, but certainly humanoid. A year after that, we got the Optimus prototype. It had improved. It could now walk smoothly, almost like a human. The bot could sort out objects based on color, as a man constantly kept shuffling them around, which would annoy me greatly if I was a bot. But fortunately, the bot is as patient and forgiving as a grandma with grandkids. It could even carry out finer jobs like picking up a nut and placing it precisely and use powered hand tools to drill a screw. It was honestly pretty cool to see. It was also the first time we got to see Tesla's neural network for bots in action. This development was possible with the advancements Tesla made with AI in the past year. And while we don't know detailed specifics of how it functions, Elon has said it works very similarly to the full self-driving system found in Tesla vehicles. And about that, we do know quite a bit. Currently, in the 11th version, the FSD system uses a rules-based approach, where road laws and rules are fed into the programming and then implemented by the vehicle. For FSD version 12, though, Tesla is trying out a learning system instead. This dictates that instead of following hard and fast rules, the system learns from footage from incident recordings, something Tesla has thousands of hours of. Basically, it studies driver behavior and emulates it. This is an important change that makes the system far safer by doing what others around you do, instead only reacting in ways already pre-programmed. This is cutting-edge artificial intelligence in action, and we saw this when Elon went live on X a while back, demoing it in his own car, with no accidents, at least none on camera. Speaking of cameras, the FSD system relies primarily on the video recordings from the cameras on the car instead of relying on LiDAR sensors like most other autonomous vehicles do. It studies the video footage and not data off sensors. That's why Waymo and Cruise have those ugly contraptions on them, while the Tesla just looks like a regular car. Now, applying that to a bot has some great advantages. Instead of using data from sensors to create an image of its surroundings, the Tesla bot uses cameras. And instead of programming the exact angle the arms and legs need to be to carry out a specific task, the AI can just observe humans and learn from that. Of course, this means a lot of observation since it doesn't have the data set of videos Tesla vehicles do. But given enough time, it is possible. We do have 5 times as many people as we do cars. And just like with Tesla vehicles, the system gets better the longer it is used. Now, this will understandably require significant computing power, but the rewards should be much greater adaptability and a lot more learning. We'd have already seen evidence of this with the latest Tesla bot demos we mentioned earlier. Those tasks should have been incredibly difficult, but the Optimus prototype seemed to sail through it comfortably. With the Optimus Gen 2 demo we saw in 2023, all of these systems seem to have been further refined. The movements are now smoother and more precise, and it's looking closer to a bot that can actually prove useful. A robot is defined as a machine, especially one programmable by a computer, capable of carrying out a complex series of actions automatically. We've had them for quite a long time, from the vacuum cleaners roaming our houses to the robots that put together our cars.